Hi everyone, welcome to QT Talks. My name's Matt Wallace. I'm the host of today's QT Talks. It's fabulous to have so many people with us today. So I'm joined today by Daniel Geater and Sukant. This is the second in our series of live chats where we share insight and information about Qualitest. So welcome everyone. It's going to be an interactive session, so please place questions and comments in the chat and we'll come to them afterwards. Really good to have so many people here today. Dan and Sukant, good to have you both, and thank you for joining.
Thank you. Thanks, Matt.
Perfect. So it's good to have you both. I think let's as people have joined, I'm going to spend a couple of minutes talking through the agenda, just explaining what is a QT talk, and tell you a little bit about Qualitest as an organization. Also share my story. Dan and Daniel, sorry, give him his due, will be telling his story and sharing some insight into Qualitest. And Sukant will be doing the same, and then we'll open up Q&A at the end. So questions in the chat, please, and we'll come to them at the end. So first of all, what you might be asking yourself, what is it? What is QT Talks? Very simple. They are a free series of monthly webinars that are hosted by myself, and I'm joined by members of the Qualitest team. The aim is really to allow people who from both Qualitest and other organizations come and get a little insight into who we are as an organization, meet some of the very cool people who work here, and a little bit about the culture of the business. As I've said before, we want these talks to be very interactive and very relevant, and there's time for questions at the end. And they're hosted live by myself, and they're shown on Facebook, YouTube, and LinkedIn. So we're very much global and viral, and they're recorded and available afterwards. So this is a slide really sort of showing who I am. So a little bit about me, but I don't want to detract from Daniel and Sukant, who are very much the stars of the show today. So a bit of background about me. I'm a bit of a geek, if I'm honest. I work in HR and have done for years in the tech sector. I can't code and I can't test. It's not really my thing. I leave that to the experts who are with me today. But so my role at Qualitest is very simple. It's people. My aim, I guess what really drives me and gets me excited is to make sure we recruit, we retain, we develop, and we grow the best people at the organization. So we've got the most talented technologists who are really passionate about Qualitest and testing. And I really want to make sure that everyone at Qualitest and everyone in the team has an amazing employee experience, and they have a platform to grow and develop their careers with Qualitest. When I'm not at work, I'm a dad. I've got a busy family man. I've got a very energetic and super competitive 8-year-old who likes to show me how rubbish I am on the PlayStation at all times. And then when I'm not sort of doing family stuff and I want to chill out, I'm a bit of a foodie. And I love cooking and eating out when I can, and then to kind of manage the waistline and keep myself in decent shape. I do a lot of running, climbing, go mountaineering up to sort of Wales and Snowdonia when I can. And I'm also someone who believes in kind of giving back to good causes. So I do I've been known on occasion to do crazy things for charity. So I once abseiled down a 400-foot tower in fancy dress, and also spent a few days in Brixton prison, all for a good charitable cause, I should add. So I spent a few days helping young offenders write CVs with interview prep, really to get them rehabilitated into the job market. So that's me. That's QT Talks. Let me spend a couple of minutes talking about Qualitest and who we are. Now, As the name suggests, we are a company that really stands for quality. It's very much in our DNA, and it's one of our values. And it's about what we do and who we are as an organization. We're very much the world's largest independent software testing and quality engineering company in the world. Now, many companies offer testing solutions. We specialize in it, and it's very much who we are and what we do. And we're very much experts in our field. And we've been recognized by Gartner as a visionary 5 years in a row. So it's who we are, it's what we do, and it's a place that we, as an organization, we want to attract the right type of people who want to be professional testers to grow and develop their careers with us as a business. So as an organization, we're very much global. So we are a very diverse business. We've been going for about 20 years. We're located in 7 different countries. We're private equity backed with big growth plans. Now we've got just under, should I say, 3,000 people globally, quality testers, as we like to call them, us. They're part of the team, and we hire and have very much a wide range of individuals working for us, some great people. And we hire everyone from graduates on a grad scheme up through to more experienced people. And we're very much passionate about hiring, training, and developing our employees so they can have a brilliant career here at Qualitest. We offer structured development programs with really clear defined career paths, with rotations, international mobility, as well as having options to work and travel globally. We also have a very diverse and rich workforce, and we have a number of active initiatives so that we're very inclusive as a business. And we've got, at last check, 37% of our workforce are female. So we want to have an inclusive and diverse workforce. And that for us is very much who we are, and it's part of our DNA and culture. Now, we are also very much a customer-centric business. So we are customer-led as a consultancy, and we work with our customers as trusted partners really to deliver bespoke testing solutions on a wide range of technical technologies. Now, I'm not going to pretend to know what they are. I will leave that to Dan and Sukant. They are very much the experts in their field. But because of our commitment to testing, we're very customer-centric, and we offer a range of kind of bespoke solutions, everything from kind of managed testing services through to strategic consultancy, to offer really a tailored QA solution for our customers. So that's who I am. It's a pleasure to have so many people on today's talk. As I said, I thank you for coming. Thank you for joining. I'm going to hand over to Dan to share his story and tell you a little bit about him and his experiences at Qualitest.
All right, thanks very much, Matt. So thanks for joining, folks. My name is Daniel. I'm the VP of AI Delivery at Qualitest. What that means is when you think about AI and quality, the two things collide in two very specific ways. One of them is how do you control the quality on artificial intelligence systems? And also, how can we use artificial intelligence to improve on how we deliver quality? I'm responsible for Qualitest projects that deal with both of those. How did I get to here? So I've had a bit of a interesting bounce through Qualitest, I would say. I've been working in the IT industry for probably about 12 years now. And I've done many, many things in that time. I've sat on both the development and testing side of the fence. I've worked with web apps, mobile apps. Within Qualitest, I've done an awful lot of automation, performance work, technical testing work, agile transformation. I've done consultancy with the company in a variety of different ways, to echo a little bit of what Matt was saying about all customers, great and small, and locations around the globe. I've been very lucky to do a lot of that. But these days, you usually find me based out of one of Qualitest's UK offices working on our AI projects. And when I'm not doing that, you will usually find me in the kitchen cooking up some tasty treats. I'm very much a foodie. I'm also very, very technically passionate. So if I'm not doing IT for work and I'm not cooking, I'm usually doing IT stuff at home. So what I want to talk about now is to bring us back to where we've come up with this conversation about telco and AI. Telco has had a very interesting journey over the last 5 or 10 years, as has all of IT delivery, really. We've achieved some massive changes in the last sort of 5, 10, 15 years. Just to recap on what some of those things have been, we've seen this change to infrastructure as code. We've seen this happen not just in the world of telco. We've seen this happen in desktop software, standard web applications, a lot more virtualized hardware these days. No need for a shared environment that 15 people are arguing to try and get to. Within telco, we've also seen this rise of 4G, 5G. You go back sort of 5, 10, 15 years, you were lucky if you could get 3G data. These days, 4G is the norm, and many, many people have access to 5G with blistering speeds of data. But the consumer provision also changed. We went from, very, very simple, if you could get data access on a mobile phone, mobile consumption, to very, very different pattern of the way content is delivered. If you look at the way the rise of the smartphone came about, the rise of hyper-connected websites, social media, we saw this drive for a lot more mobile-first content. We started seeing this push to get everything delivered to handheld devices. But telcos don't just deal with your standard smartphone or feature phone anymore. We've got an awful lot more connected devices and technology being provided for. For instance, we've got people quite often have hotspot plans. We've got vehicle infotainment systems. We've got wearables. We've got eSIMs. We've got internet connected devices. Networks are connecting more and more than they ever have before. We've also got consumer home network changes. We've gone from the point where you might have had a sort of a 56K clunky dial-up modem that screeched and rattled quite a lot as it connected, to the point where we've seen the rise of broadband, and now we're in the world of fiber optic broadband, 4G, 5G home connectivity. What we're trying to get across here is that more network functionality is being designed, developed, and delivered faster than it ever has been before. And sustaining that level is very, very difficult. Much of what we have today, commonplace, was not even dreamed of 10 years ago. So where does this leave quality? Quality faces a very specific challenge as we talk about the new ways that we consume our content, provide our content, build, deliver, deploy our content. We're talking really about a problem of growing complexity. We are trying to build systems that are beyond our ability to intellectually manage. And if you think about what really goes into the process of getting you your latest Facebook update all the way through the network presented to your phone, there's a huge amount of moving parts that have to work together. Even the devices themselves are incredibly complicated. A modern high-end car has about 100 million lines of code in it. A modern passenger jet has about 30 million lines of code. A modern banking system, about 20 million lines of code. A humble smartphone operating system has in excess of 15 million lines of code. And if you look at this from a quality perspective, that is a vast amount of data. I mean, sure, some of those lines of code are going to be, maybe it's just a brace, maybe it's a blank line. It has long been a truism of quality that lines of code alone is not all you need to know. But we can see just by the sheer orders of magnitude here, we're dealing with a huge amount of software going into our day-to-day consumption that we need to deal with. And the quality of that software can be controlled by many different things. Some of those things that control our quality can be internal angles, or they can be external angles. In other words, it's not just about what am I developing, what am I delivering, what am I building. It's also about everything that's connected. And this is readily apparent, particularly in the world of network spacing, where you've got multiple different vendors, you've got multiple different appliances. But let's take a step back from it. Let's just consider a basic software application, something like a web front end or a desktop, or maybe even a smartphone application. You expect to see, a few hundred user stories that define what we're trying to do. Maybe they're requirements if you're not in the user story spacing. Those user stories and requirements are taken away, and they are coded by developers who will come up with several thousand commit messages to implement each of these stories. Off the back of these commit messages, quality engineers are going to design, build, and execute test cases. And for a handful of features, you'll usually get several dozen test cases. A few hundred user stories and features, you'll use each piece of functionality needs to be tested in a few different ways. And we know as quality professionals that most test cases are not just run once and then forgotten about. Most test cases don't even pass the first time they're run. So we need to keep the history of understanding what's going on in my testing. So we've got several 100,000 historic test execution runs. Some of those test execution runs where they fail will result in somebody raising a defect report. Something isn't quite right in the software. And we also know that quality doesn't stop when the product ships. If we want to pay attention to what is the quality of my application, I also need to pay attention to those annoying little quality glitches that slipped right. So if we think about those 100 million lines of code, or 20 million lines of code, 15 million lines of code, if we think about all the different places that quality can be measured and controlled, it's visible in each and every one of those points. You know, quality is defined by the user stories. It's implemented by the developers. It's tested and assessed by the test cases. The lack of quality is measured by our defects and our support tickets. If we want to think about how do I focus my quality so I can continue at this pace of delivering new content, I need to think of all of that. But when we talk about telco networks, another layer of complexity. It's no longer just about what controls the software. We've got the complexity of the network and the user equipment itself. And what do I mean by that? Well, let's say that our delivered piece of software is some kind of mobile content offering or maybe a new protocol. We've now got to start to think about, well, what about the device operating systems? You know, at any given point on the marketplace, there's maybe 10, 15, 20 different supported versions of the big operating systems for Android and iOS. We've also got the fact that many different devices and network appliances are side-loaded with other software. Sometimes that's utilities, maybe it's your network providers tracking and billing apps, or maybe it's actually at the hardware level. Maybe it's something like, you know, a slightly customized version of the operating system. For instance, with Android, very few Android devices ship with pure Android. A lot of them ship with manufacturer variants. But as we talk about networking, we've also got protocol evolution. Over time, the way the network devices at the lowest levels move their data around changes. The protocols evolve, but at any given point, we may have legacy versions of protocols also need to be supported. We mentioned briefly that we've started to move away from just physical hardware networking now. We've got software networking. And in a modern telco, you'll quite often find physical and virtual variants of the same network appliances. They may even be running in parallel. They may be running slightly different configurations, but we need to be able to deal with this. Networks grow additively and in layers over time. There are parts of modern networks that go back a very, very long time and have been built up on. We very rarely take things out of network architecture. Lastly, we've got to deal with the fact that networks form critical infrastructure for many, many organizations and even many nations. There are very, very strict requirements on non-functional behavior, regulatory compliance. All of these functions add other layers of complexity on top of what we already knew govern the complexity of delivered applications. So where does this get us? What it really means is that finding out where quality needs to be focused is incredibly difficult. And if we want to keep continuing software and network functionality at the pace we have, we need to find a way to manage it. We can't just test harder. The different combinations of configuration, application, software, and specification make it unviable. Even with some of the most sophisticated automation in the world, it is almost impossible to test everything. So how do we test smarter and focus our testing? How do we make it so that that unmanageable complexity is enough for us to turn around and say, you know what, this is where I need to test today? We can think of this as a big data problem. All the levers that control quality can be thought of as combinations to test. And the problem is that for manual test engineers, it's very difficult for us to hold all of the combinations in our head about where the different things need to be pressed, where we need to test. Has this been tested before? Has it this way? Has it been tested that way? But machine learning, artificial intelligence, and data mining paradigms make this very, very easy for us. Artificial intelligence has commoditized in unique ways in the last 5 or 10 years. And a lot of it is off the strength of its ability to take big data sets and crunch them down. It's not a coincidence that the rise of AI also came with the rise of big data. We can use machine learning to draw the information on all of those quality levers and find the patterns that lead to markers in quality. Because at the end of the day, what most software test engineers are looking for is the quality problems. We'd like to be able to say we tested every single thing, and this is where the good quality is. But what unfortunately happens a lot of the time is our testing gets reduced to finding problems. We want to find those problems first. We want to find them earliest. The reason we want to find them first and earliest is because the earlier we find the problem, the better the chance the problem gets resolved. So what we're talking about with artificial intelligence and testing is quite often How can I make sense of the different ways I can test to increase the risk of finding the problems and minimize the risk of a substandard product going out to my customers? Within Qualitest, we manage a lot of our artificial intelligence applications for quality management through our QualiSense tooling. QualiSense is Qualitest's machine learning and artificial intelligence appliance, which we use to draw data from different parts of your organization's quality history and understand where, and let us focus on how to improve our quality paradigms. So I'm going to talk for a second about some of the areas we can actually use artificial intelligence to help with quality. If you think about the main milestones in software testing, we can see little opportunistic ways that artificial intelligence can help. We are a long, long way from testing robots. We're a long, long way, and the day may never come where artificial intelligence completely replaces human testers, but it can support us. It can help us speed up what we do day in, day out with testing. For instance, if we take a look at test strategy, test planning, we can use artificial intelligence to analyze those historic systems, the details of where quality has been measured, managed, controlled in the past, and identify quality pitfalls, help us plan things, help us better prioritize the testing we want to execute. That point a moment ago about let's find the problems earlier. A lot of test engineering time is still spent creating test cases, the actual written instruction or automated instruction of how do I exercise this piece of functionality. Well, we can use artificial intelligence to generate some of our test collaterals for us. We can use artificial intelligence to pay attention as we execute testing and help us speed up the process of debugging, analyzing, and tracing failures. This is a big area for telcos, and Sukant's going to talk about it in a little while. And we can also use artificial intelligence to help us spot trends in quality to better inform future iterations. We can use AI in many, many ways to help us with small, repetitive tasks that slow down our testing to let us focus on the bigger picture tasks that drive quality as a whole forwards. So I mentioned that within Qualitest, we do all of this with our QualiSense tooling. QualiSense draws its information from across the landscape of your quality management. What do I mean by that? Well, if we consider those levers for control we talked about, we can group them, loosely speaking, into 4 different families. We've got development information systems, in other words, the details about requirements, user stories, configuration management, change management, what was actually in the application at a given point in time. We've got test management systems, the details of how do I know what quality controls I have? What test suites do I have? What test cases do I have? What test data do I have? What environments can I run this configuration versus that configuration against? We've got test execution data. We've got the details of when the tests were run in the past. Did they pass? Did they fail? Were there defects raised? Were there issues raised? What about error logs? What about trace files? What about the kind of information systems that let us know exactly where testing did or did not go quite to plan? And last, we've got production systems. With the best will in the world, it's very difficult to test every single avenue of functionality within the lab. And production systems are often very, very useful in helping us monitor post-life quality, whether that is something like support ticketing systems, whether that is ops logs, whether that is SIEM receivers and the like. Again, what we're trying to do here is understand that quality is measured and measurable in many, many parts throughout a software or network functionalities delivery. And drawing that data, we can feed it into QualiSense to start to apply machine learning and artificial intelligence to let us bake better quality into our products. So a few specific use cases that I'd like to talk about here. On this slide, what you're seeing is the 4 main areas that we often come across artificial intelligence and quality as the most tactical use cases for applying artificial intelligence. You've got the idea for things like test case prediction, failure prediction, the understanding of where should I focus my testing. We've got test case consolidation. It is inevitable with the amount of application functionality we deliver, the speed at which we deliver it, the number of different people involved, that we end up with some duplicated testing effort. Now, quality is already feeling the squeeze. Quality assurance testing are already feeling the squeeze to get all the testing done. We definitely do not want to spend time running tests that have already been done and covered elsewhere. We do want to cover the breadth of the applications and the networks, but we don't want to overdo it at any one point. So we can use artificial intelligence to analyze our test history and understand where maybe we over-tested or under-tested in the past and let us more evenly focus. We can use artificial intelligences to improve our processes, to understand, for instance, this is how we tend to deal with defects. This is how we tend to deal with requirements, test cases. We can improve the life cycle of those individual bits of test collateral. We can work with application scanning tools and application analysis tools to help our engineers understand what the important parts of reporting and data coming out of these things are. We can help find the wood between the trees. But we can take those same data points and we can also see where people have interacted with our quality, with our processes in the past. We can use artificial intelligence to look for insights. For instance, we can look where patterns turn up in how test cases or defects or phases of testing are managed, and we can use that to govern process improvement. This is more what we're talking about in the bottom left here, AI-powered consulting, taking our understanding of how we deal with continuous improvement, quality improvement, and inform it based on artificial intelligence and analysis of what we've done with quality in the past. Mentioned briefly before, the other common intersection with artificial intelligence and quality is the other side of the coin. If we're developing or delivering artificial intelligent behavior, how do we assess the quality? These systems, by their definition, are not like systems that came before, and some of the quality paradigms don't quite line up. But we can use the tooling and capability of QualiSense to help with this. And lastly, within every single industry, within every single company within industry, there will be very specific use cases that make sense for that one area. For instance, there are considerations that the consumer parts of telco testing have that the business parts of telco testing will not have, and some of these will be considerations that don't even apply outside of telco testing. Similarly, with things like billing, actual networking, IT and operational software, and the innovation of testing, there'll be very specific use cases. Now, I don't want to go too much on this because I don't want to steal Sukant's thunder, but he's going to explore for us one of the very specific use cases and how we can help. What I've tried to do here is just give a bit of an overview about how AI is starting to shape and refine the way we deal with quality. Thank you for listening to me so far. I'm now going to pass back to Matt.
Excellent. Thanks, Daniel. That's brilliant insight there. I was going to say I learned some stuff I really didn't know. So thank you for being sharing some brilliant insight there. Sukant, over to you. Your turn now. I'm sure you can educate us on AI and tell us a little bit about your story and time at Qualitest.
Sure. Thanks, Matt. Firstly, thanks, Matt, for hosting QT2. It's such a fantabulous initiative by QT to showcase our cutting-edge technology in some niche area. Thanks, Dan, for showing that in-depth outlook of what QT is doing in AI. And thanks, everyone, of course, for taking time today for our QT Talk episode 2. Who I am? Maybe an artist, already running out of walls now with my paintings everywhere rolling around. Do some kind of vocalist, really. The picture you can see at the top was the last year performance at North London Town Council, which ultimately went for a cause of charity. And I'm an online filmmaker.
So, Sukant, just looking at that picture, and given that you say you're an online filmmaker, are you sort of telling the audience that you're basically a YouTuber and a rapper when you're not doing testing?
Yeah, that's right.
No, I love that.
That's actually right.
Thank you for sharing.
Yeah, so yeah, that's what I do. So basically outside my working hour. So what I do in Qualitest, basically, I'm a lead quality engineer and a test engineer. My day-to-day work revolves around testing end-to-end network, testing IT, testing device, and a lot of those testing. And I have been working in AI models for last like over a year to squeeze those areas which we are going to discuss in our slide. So basically, I am a quality engineer by day and a vocalist and a filmmaker at night. So that's basically about me. So now let's talk about what we are going to see, right? So let me put in this way, like, have you ever wondered what's the most challenging task for a tech person, irrespective of domain, industry, or whatever it is? Uh, I think it's the troubleshooting, right? So we as a tech person, irrespective of developer, designer, support, we look for that specific log to ink our mind to isolate that bug. In this presentation, we are actually going to unravel this existing trend in the telecom, bit more precise in the network testing by implementing the AI model through various testing and training algorithms. So you see, before digging into this business data, let's try to understand and correlate what's the real pain point is, and what's our what as a qualities, what's our real USP. Yeah. Uh, so let's say I'm a support specialist, or I'm a designer, I'm a tester. As a tester, I do a test, I raise a defect, right? Then followed by the support who understand the problem, then start troubleshooting, analyzing those PCAP files, those ISA trays, those val logs. Those are huge, right? So once identified, either as a support, he will give the resolution, or it will route it to the design for a bug fix on that particular module of any function. So if you see this life cycle, where do you actually find the most painstaking task? That is actually the troubleshooting, right? We end up spending enormous amount of time in analyzing those logs. We end up spending enormous of time as a designer to identify that particular function where my bug is. So with our AI model, we are actually condensing this approximate 185 business hour. Now let me tell you what this is actually the time we are spending in a project which is actually spread across a duration of 1.5 year by raising defects at a various priority. It can be P1, P2, P3, and so on. What we are doing is we are trying to not completely, but we are trying to condense this 185 business hours. So basically, we are trying to reduce the troubleshooting time with our AI model. So thank me later when you don't have to procrastinate your plan for a beer with your friends in the next game. I'm sure. What's next? So using AI, how we are going to use this? So if we go further in the next, you can see that as mentioned in the previous slide, we are not with this AI model, we are not restraining our we are restraining our focus right now into the various very hyper local part of the telco. We know that it's a juggernaut platform, but keeping a note that this model can be quantified in any of the domain in the industry, whether it's IT, BSSI, or pharma, or anything. We can correlate it later. So in this slide, you can see a very generic, a defect flow model, uh, just to concave our focus that what we are trying to implement in this current defect flow, which currently we see as a pain point, and we spent relentless hour in that particular point. You see issue discovery. So as we discussed, that issue discovery is where we as a tech person spend a lot of time in breaking our head, identifying that code, identify that log in our day-to-day life. So if we go further, we can understand that what we are actually trying, as we have understand from the previous slide, what we are trying to do is we are trying to squeeze this issue discovery process with our AI model. So laddering our focus while executing this test scenario in the test bed, we know that as a tech person, there is no scarcity of data. Whether we say an telco, whether we say an software, whether we say an banking, we know that we have a huge amount of data. When we say a PCAP file, when we say a dump file, when we say a debug file, we have huge data, and that is what I need for the pedigree of AI is data, and we have a lot of that. So if we see that what we are actually right now doing in the next in the next slide, if you see that is, so this slide is basically what we are doing right now. And so this is, I think this is very much everyone can correlate. So we have a test environment, we run a trace, we take a trace, then the manual review starts. if I'm a support guy, I will review, as I told you, if I'm a designer, I will look for that code. So as Dan mentioned, if I have a driverless car, I cannot go and relentlessly work on those 10 million lines of code. Who is doing that? That is nothing but that is a wizardious work. That is what AI model is doing. That is where we are actually concentrating on. So if we go to the next slide, in here, if we see, so this is the real wizard play is actually happening. So this is where I am taking those data, taking those labeled data, supervised data, putting into my model. But as I always, as I always do, before diving into any complex I want to generalize it to a wider community. So let's take this example before diving into this slide. How the driverless car knows. We know what is driverless car. How does a driverless car knows that when I have to pull the brakes, when I have to pull over, when I have to slow down? How does it know? It's all about taking those unpredictable images and videos with that specific vicinity, right? Now, once I have get the data, I will put those images at the runtime into the AI model, which is powered by Python or R. That is again a different world, and make a decision and make a mechanical decision that, hey, you have to pull down, mate. That's not going well. Yeah. So now let's come to this particular model. I hope everyone is now, can correlate that, what we are actually, talking about. So if you see in this training model, till manual review, till message detail, if you see that block, message detail, we have the protocol, we have the source, we have the destination, we have the host, and blah, 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 all those stuff. Similarly, if you are from the, suppose if you are from the driverless car, what is my data? My data, as I told you, it's an image, it's a video, right? Now, when I acquire that data, I will put that particular data into our model. So those are actually the AI model, which are supervised, unsupervised, decision tree to make the decision. Those are all models, right? And so there are a lot of models which, as a qualitist, we have been working on. That is again a completely different world, which we may not be covering on this particular scenario, but that is where in the next slide I'm going to talk about that how in the network area we are going to isolate the nodal fault. So now you have understand that how and why, what we are doing basically, right? We are taking those data. Now what we are doing, we are putting that particular data in the machine learning model. So now suppose I make a call, right? I make a call and my call gets failed. What's next? I will get the data. Now I will keep looking for that. I will identify the fault. That's what we are not doing right now. We are getting the data. We are taking that entire PCAP trace. We are putting into the machine learning model. Now, if suppose I have an IPv6 stack which is not getting allocated at P gateway or any other network element, it is the job of the machine learning to identify that I have a missing IPv6 from a router file. How it is doing? So first, in that particular scenario, first what I have to do is I know my network is a juggernaut. It's a massive thing. I have thousands of nodes. So first, my decision tree is making a decision that where my fault is actually located. So as I told you, that is again a completely different world of coding the model, designing the model, completely different, which is not in scope of this. But yeah, getting the model. Now we are isolating our fault at the P gateway level, followed by unsupervised machine learning, which is basically we are using anomaly detection. That in P gateway, what issue I really have. Suppose in a router, I have a missing table, which is making the routing to a different node. So my unsupervised anomaly detection is basically identify the exact pinpoint of where my fault is located. So boom, I as a support or I as a designer put my data into the machine learning and you get how much time it will take. It takes a few seconds to identify the bug and that's it. So that is we are we are doing at Qualitas. So if we go at the next information, you can see that what is the time difference now. Real business game is actually happening over here. So till now, or many of us suppose I have a P1 defect, right? As a designer or a support, my TAT is around 60 minutes. That too, I'm not sure whether I will be able to make it, or it will go to next level of support, level 2, level 3, then design. What our machine learning is doing, boom. So you are getting that case, putting into a machine learning, that's it. You find out everything, it's all sorted. Now the last bit is that coding. So I have found out where my actual code is. If it is really a code changes, then the designer will go and fix that code. So it's a matter of just 5 seconds, guys. So really, this is something, a magic happening in front of your eyes. So if we go to the next one, so this is so takeouts and learning. This is something which is very crucial. Look, so now as we have discussed, so AI model is actually a hungry boy for data. It needs data. That is what it needs. And we as a software developer, we as a tester, we as a support, we have it. So we know data we are having, then we are followed by data preparation. So data preparation in the sense, we have to label those datas. Then we have to choose the model, which I have already discussed on the slide, which model we are using to identify the troubleshooting. There are many models across the machine learning that a designer or an architect have to design which is the most appropriate model to do the predictions. Yeah, then train that data. So this train those data, it means more training means more accuracy. So let me give you a very quick example. Suppose in an Amazon, if you purchase, suppose if you purchase a pen, right, and if you know that you like a Parker pen, so if you purchase one, Amazon AI will not know that you like a Parker pen. You have to train it. So next time when you purchase, its model is more predicting the values that, hey, that guy is liking Parker pen. Let's give him more suggestions, right? So that is what as actually training. You have to train more and more data. Evaluating the model, of course, you have to identify what my model is giving out as a answer. Then parameter tuning. So there are certain things in parameter tuning, like there are certain predictions where we have to give an approximate value, certain prediction where we have to give an exact value, such as, for example, driverless car or a Falcon space shuttle, where we cannot have a chance to lose an opportunity and to make faults. We need an absolutely 100% accuracy. So that is a fault in fault matrix, where if I have a brake failure issue, the AI algorithm will rectify that break and make the things happen at that particular time. That is basically, we are tuning the parameter by putting some hyperparameters. So that is again out of the scope of this particular the webinar. Then make predictions. So make prediction again. What predictions you are making? So suppose I want to make prediction that what will be the population of UK at 2020 on the basis of the census which we have now. We will use AI algorithm. You cannot run across taking votes and taking online forms that, hey, what's your, you cannot do that, right? And the retention is also very low. So that is what AI. Sit at home and enjoy your time. So if you go to the these are all the takeouts and learning of what we basically are doing. So on further, if you see, yes. So what to Matt?
Thank you, Sukant. That was I was going to say that was fascinating to hear. I learned a lot about the AI in the telco space, and it's amazing to hear that you can, with some simple data intelligence, you can save minutes, hours, time. You know, to actually save time is phenomenal. Thank you for sharing. I guess on behalf of everyone listening, thank you to Daniel and Sukant, our rockstar testers. Thank you guys for today. We will now kind of take some questions and some Q&A. So Sukant and Daniel, if you could both come off mute. We've got a few questions from everyone listening. First of all, thank you everyone for joining us. It's good to see we've got such a global audience from as far as the UK, Portugal, India. It's good to know we've got a massive global following today. So thank you everyone for joining. Please put your questions in the comments and we will come to them. So I guess Daniel and Sukant, one for both of you first. If you were to share one top tip or piece of advice with everyone listening for those who want to become developers or testers, and rockstar developers and testers like yourself, what would you say? So Dan, over to you first.
Rockstar testers and developers. I think my biggest one would be don't be afraid to fail. It's very easy to try something and not have it work, and then you put it back in the box and you never touch it again. I think it was Thomas Edison said he didn't fail, he just discovered 10 million things that didn't work. And I'm a big believer in that approach. Every project I've ever worked on, I think there's always been a little bit that you take it, maybe it didn't quite go right, you can bring it forward, you can learn from it. Take those experiences with you, and it applies as much in Selenium test automation as it applies in manual exploratory, as it applies in artificial intelligence. More so in artificial intelligence because the widespread use of AI is so much newer. We're still learning so much about how to do it. So don't be afraid of those failures. Take them, examine them, work out why it didn't work, and then make it a little bit better next time.
Yeah, no, I think that's brilliant advice. And I guess I live by the mantra, try and try again, and always learn from your failings and challenges. So I think it's a brilliant piece of advice, Daniel. Thank you. Sukant, same question to you. What sort of piece of advice would you give everyone listening to today?
So thanks Matt for that question. So let me put it like that. So if you want to be a rock star outside your professional, then you can reach me out. I can teach you some vocals.
Learn to play guitar. Rock star.
Jokes apart. Now,
so rock star or rapper, probably in your case, Sukant. Let's be clear here. Yeah.
So, but if you want to do a rock star in professional, then the most important thing is that you should always be looking forward of what you are doing at the moment. You should always look for and upscaling yourself. You should always look for something which makes your work easy. That is what I have always believed. Yeah, you cannot use a lot of time in doing your doing your task. You're doing your existing task or predominant whatever task it is. You have to find a solution to make your things easy, right? That is what the future is. So it's very generic. I mean, there can be school grads who are on this call. So always think it doesn't matter whatever area you are. You always have to find out a simpler way of what you were doing yesterday, right? You should always look for that, and that is what is the future. The future is making things simpler, right? So that is what my extremely generic piece of advice. So rest all, I know people are extremely talented on this call. They are designers, they may be support, they know what to do and what not to do. But this is just a generic that look forward to simplify your task. If you are a coder, just simplify it. Yeah. So
no, I love that. You're absolutely right, Sukant. Make life simple, keep things simple. It's certainly one of the mantras I live by, and I think it's a fantastic piece of advice. Thank you, guys. Actually, a question from Neha, Neha, thank you for joining us today. Nihal's asked actually why should we join Qualitest? What makes us different from other software and testing companies? Certainly, I can give Nihal my view and views, but I'd love Daniel and Sukant. You've been with the business a little bit longer than I, so it'd be good to get your views too. So Nihal, I joined because I'm passionate about working for fast-paced tech companies. We specialize in testing, but we do all manner of kind of development as well. So I love working for global businesses that are fast-paced, that support career progression, and I love working with people who challenge me. And that's why I joined the business. I guess same question to Daniel and Sukant to you. Why would people want to come and join Qualitest, and what makes it different from other technology businesses you both have worked for? So Dan, you go first.
Sure. I think for me, it's probably the variety. Qualitest is a company that we will test anything. It is true we're not like one of the big SIs. We're not developing. We're firmly focused in the world of quality and testing. But within that, functional through the non-functional, we'll do all types of system under test, everything from telcos and networks through to mobile phone applications, set-top boxes, websites. And within the company, we are very, very good at putting people where they need to be and in places where they are needed, if that makes sense. So for me, in my time with the company, I think I've been with Qualitest, I'm just coming into my 9th year now. I've moved around quite a lot, and I've done radically different things in many different ways. Like I said at the beginning, I've done everything from functional testing through performance testing through automation, which for me personally is fantastic. So it's great for me to be given these new things. But I think it's also a fair testament that Qualitest can work with whatever your software, whatever your challenge is. And if we don't already have the answer, we're more than happy to find it. So it's a very, very good place if you like solving new problems, you like variety and diversity.
Brilliant. Thank you, Dan. Sukant, same question. I guess why did you join Qualitest? Because you've got a rich history in the technology space. So what makes it different as a business, and why do you like working here?
So the best part with Qualitest is that I'm not only focused to my day-to-day testing, but there are a lot of diverse opportunity which I get over here. So it is not only about testing. I have been working on AI stuff, and there are a lot of other stuff. So if you are a support or if you are a design, in Qualitest, you get a rich opportunity to work across any domain, parallelly working with your day-to-day activities. So that is what I like, and that is most fascinating thing, that every day when I open my laptop, it's new. I learn new things. I learn a lot of new technology, cutting edge technology. You are not being confined to what you do if you are a tester or if you are a developer. So diversity is what I think that is the strongest point in Qualitest. And if anyone want to really work in cutting edge technology, this is the one-stop solution for you guys.
Yeah, no, it's a brilliant insight. Thank you, Daniel and Sukant. And I think we've had, looking at the comments, thank you everyone for your questions. For those that have asked about positions and working for Qualitest, you can see here that we are hiring. We would love to have chat with people further. So there's a link to our careers page. Please do drop us an email, get in touch, and we can talk some more. One of my team will talk to you about opportunities in the UK or elsewhere in Qualitest. We are, as I said, very much a global business. So, and if you're interested and you enjoyed what we've had to say, then let's talk some more. I guess Dan and Sukant, question for you, and thinking, taking taking the subject back to AI, because it's a fascinating subject, certainly for me. And today, what's the message I've had today is AI is all about data, and it's the smart use of data. So I guess question for both of you, is there such a thing as too much data in AI? Daniel, what do you think?
I think it's a great question. There is a truism to AI that I think everybody's probably heard by now that's even touched on the field of it, which is bad data in, bad AI out. The quality of data is vitally important, but so is the volume. You can't make an AI with only 2 records in the input training set. It just doesn't work. But at the same time, you want to learn from as much data as possible, right? You want to be able to know that everything that can be reflected in your data set has been, so that AI has had a chance to learn from it. But when you consider the volumes of data that we as testers generate on a daily basis, whether that is the gigabytes and gigabytes of information captured in a capture file, or whether that is, let's say I want to train an artificial intelligence on the last 10 years of this product lifecycle, it is very, you can very quickly almost have an explosion of the number of data permutations you want. So in an ideal world, no, there's no such thing as too much data. You'd like to be able to learn from it all. In a practical world, I think there is a very delicate balancing act to finding the sample size that works for you. Artificial intelligences are computationally still quite expensive to train, particularly when you look at things like deep learning problems. Finding the data balance that is right to train one of those in a cost-affordable measure, I think that's an important part of it. You don't want to take all the data and then discover you can't actually make any progress because you now have to wait several years for it to finish training. Okay. I don't know if you've got any other thoughts on that, Sukant, or you want to add to it.
I'm with you, Dan. I'm with you. I have the same opinion as well. Like data is what the pedigree is for AI, and that too quality data. Yeah. So it's very generic. Like the more we read, the more we make ourselves perfect, right? The more we read, the more we analyze the data, the more our predictions will be perfect. Yeah. So that is if I say that, if a one-liner, I think that will be the one-liner for this. The more we read the data, the more we will be perfect in what we do.
Yeah.
Same with learning.
And do you, Sukant, just thinking out loud, can you, and Daniel, same question to you, can you, obviously it's work, perfect data is what you want and aspire to, but can you work with substandard data? Is there flexibility in that? I'd love to get your views.
So from my perspective, the data quality is very important, but I think a lot of people are almost afraid to start an AI project because they're concerned the data is not right. And I think I see this more with AIs that are trying to train on data that has been manually generated, manually collated. It's come from this team and that team and that team and that team, and I'm worried that it's going to be inconsistent and so on. And it is a valid worry in that if the data is completely inconsistent, you're going to struggle. But generally, I tend to find, certainly working with QualiSense projects, that we can work with less than ideal data, because within machine learning itself, within data science itself, there are techniques that let you fill in within certain data sets. And there's also the fact that from a process improvement angle, missing information is still information. You can help people understand that, maybe the data is not quite right here. Why is the data not quite right? Why didn't we capture it the right way? And we can use that to improve the way we do it. So we can say, I'm going to make a model now, and it might not be on quite perfect data, but it gets me a little bit further forwards. And at the same time, I'm going to use this understanding of why this one isn't quite right to improve what I could do next time. And we can work that way. It comes back to that don't be afraid of failure argument. So yes, perfect data would be nice, but I do also think we can work with slightly less than ideal data. There is obviously a bottom point where it's not workable, but I think that might be lower than some people think.
Great question there, and thank you, Dan. That's good insight. I guess, Sukant, any thoughts or builds on that?
Yeah. So as Dan referred, that data, we need a quality data. That is absolutely right. But there can be as we have discussed on the slides, we have a concept of hyperparameter, but again, those are all may not be in the scope, where we have an opportunity to tweak those data, which is giving some inconsistent predictions. So that is something on future, like how it will go, and that may not be relevant to this slide. So that's absolutely right. As Dan mentioned, data consistency and quality of data is of course needed. That is what makes our prediction more accurate. We do have the hyperparameters where we tweak those data if we are observing any prediction bifurcation. So yeah, so that's basically my take on the quality of data and how we can how we can transparent it in going in our future for AI technology.
No, I think brilliant advice from both of you. Thank you so much. And I think Dan and Sukant, on behalf of myself and everyone who's dialed into and listening to today's call, thank you for sharing your time. Thank you for your brilliant insight. It's been, from my perspective, and I'm sure for all of the listeners, a fascinating learning experience. I know we've had some amazing comments, and I have to say, Sukant, I think you've got a bit of a fan base there based on what you've shared. So thank you to both of you. For everyone who's joined the chat, thank you for joining us. As I said at the start, QT Talks is a free monthly webinar. It's a series of webinars hosted by myself. Thank you for joining us. We will be sharing details about the next QT Talks. Dan and Sukant, I'm sure, will be back on a future talk by popular demand. So please look out for them at some stage. But I look forward to joining everyone on the next QT Talks in November. And everyone who's posted a comment, we will get back to you. And for those of you that expressed interest in learning a little bit more about Qualitest, we will be in touch with you. We are certainly, from my perspective, I've really enjoyed and enjoy working with Dan and Sukant and other people in our amazing team at Qualitest, and I'd love people to come and have conversations with us in a little bit more detail. So thank you everyone for today. It's been a fantastic talk. Thank you, Dan. Thank you, Sukant, and thank you everyone for joining.
Thanks for having us.
Cool. Take care. Bye, everyone.
Bye-bye.
Bye.